I got thinking of this the other night, anyways, whatever day it was. This is Thursday, right? So Tuesday night on the way home, I got thinking. I've been giving you equations, but I think I probably should give you a list of equations so you have them for control charts, make your life just a wee bit easier. So we're going to go back and do that today. And then the other bit will be making sure that you're okay with me giving you a midterm online that you can go play with for next week. I got a list of questions put together here, but I want to make sure topic-wise you know what they are. And then after midterm, we'll come back and finish up some more. Next week. We still got a week, don't we? We'll get into some more control charts, but I didn't put control charts on the midterms, not finals. Sorry. All right. Let's do this. So for an NP chart, you're looking at CL for control limit. Okay. The upper control limit Okay. This is just to help you later on in life when we're actually trying to put stuff in here or in the chart. Can I get N, P, 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 and then C? Where's my P? Poisson distribution. Poisson. So also remember, P chart is the one we did the other day. That's the percentage. Okay, number of percent of defects. Okay. All right, and this has upper control limits. So I'm not going to write the whole thing out again. I'm just going to use the abbreviations. So our upper control limit for a C chart is the average C plus 3 square root of the average C. Okay. And then the lower control limit is the average C minus 3. And we're looking at square root of the average C. Wait a minute. I put P chart up here. Oh, man. Sorry. This is a C chart. Okay. Sorry. And as long as we're in here, I'm going to put a few notes in too, because all right. What I want to explain is this with the note. Number of defects divided by the unit data, that there is a constant area of opportunity. So think of it like this. I got a car assembly plant, and I'm watching the number of cars that come off the plant, but it's one particular line. It's not like I'm watching 7 lines and trying to figure out what that is. If it's a construction project, it's one set of apartment buildings that are going up, not the entire 150 apartment buildings. Okay. So the area of opportunity has to be the same operation that you can count defects in. Okay. Make sense, Luke? Okay. So I want to go one further with that. So let's say it's an apartment we're building, 12-story apartment complex, but there's another crew building another 12-story apartment complex. So it's not the same people building it. So I can't count a different work crew in this same set of data. Make sense? So it's got to be the constant area of opportunity. So you guys are my workers on complex A, then you're my workers on complex A, but you're not going over to complex B to work. Somebody else is doing that job. Make sense? But if I had you going over to complex B and you're working on complex A also, then you are the same area of opportunity. Okay. You may never remember that the rest of your life, but when you get in doubt, just look it up. Okay. All right. So with C charts, we also get a point where we need some reliable statistics, and things less than 20 do not give us good reliable statistics. Okay. Now, statistics in the world of just pure statistics, they like to see samples 14 or larger. Okay. In the quality control realm, 20 or larger seems to be something you can actually investigate and understand more about. But when it's less than 20, it's pretty hard to pick out what's causing it. Okay. So. All right. Next chart. You guys good on this stuff so far? Can I slide up? We haven't actually done a U chart, but I'm going to give you some here anyway, so you got the equations. Okay. So U-charts are good when there's a variation between subgroups and you're not, that you are looking for the areas of defects in various types. So back to my example of the two apartment complexes, A and B. They got the same operations that have to go on them because they're going to be identical. And you're looking at subgroup A as building A and subgroup B as building B. And if you're going in there and you're counting the number of, well, let's say broken windows that the contractor put in, you know, how they compare subgroup to subgroup. Okay. Yep. A, I. Okay, so C sub I is the number of defects in the sample of size I. So that could be 50, it could be 100, it could be whatever. Okay. So you take the average of it, and that's what the C is. Or that's what you're looking for is the average U. And A sub I, it doesn't look like an A, does it? A sub I is the okay. So this would be the area of opportunity. So let's say you had two buildings, so two subgroups. That's two. Is that big enough for you guys to see, or do I need to write bigger? Good? Okay. All right, so here's the upper control limit. Man, I can't make A's today for the life of me. There we go. AI. Okay. Okay. All right. Ba-da-bum, bum, bum, bum. Okay, let me get you an example here. All right, so the first way to use this is you check the control limit, and based on the average number of opportunities, you are then going to evaluate whether it's plus or minus 20%, and you get something that looks like this. So 1900 is the average, plus or minus 0.25 times the 1900, and you're going to get it's equal to 2375, and the other one is 1425. So this would be your upper control limit and your lower control limit. Okay. So this gives you a way to make an approximate control limit so you can see what the things look like without having to do a whole lot of math from up above. All right. Second alternative, So this option is when you start seeing a lot of variation that takes you outside of the plus or minus 25% of the subgroups. And what you wind up looking at is you get a control chart that looks something like this. Okay. And you have inner, upper, okay. So they give you that swing of stuff. Actually, let me take a picture of this and I'll bring it into the... That's not what I want. Insert picture from camera. There we go. So here's an example. A book publisher has counts the number of keyboard errors that are made on their way to finishing a book or books. The number of errors and the number of pages are in the last 26 publications are as follow. Okay, so numbers are there. I wrote some stuff on this years ago, but I'm going to walk you through the calculations here. Okay. All right. So if I take a look at, let's go back to black. Thank you. Take a look at A. So the minimum area of opportunity was 202. The area of opportunity for the max was 770 pages with an average area of opportunity about 452. Okay. All right. So we got our CI, our counts. We got our area, I, and then we calculate a UI for each of these. Okay. So we're going to do that over here, and then we will give you some examples to this. Okay. So I'm looking at UI, and it's going to be equal to CI divided by the area of opportunity, and that's going to give me No, not doing that one. Hold on. UI. And if I take all these C's, number of errors per page, and then the number of pages, I can do this. So the sum of all the CIs will be 1,200, and the number of opportunities will be 11,749. Okay. And that will come out with a average of 0.102. And then I can start using that number to put things in effect. Okay. There's another way to do this one, and I take the average and we count up all the, not count up, but we take the CI divided by the area opportunities here. And we're going to get a number that looks like 0.116, which is based on finding my highest and lowest numbers here and playing with them. So for instance, take each one of these and calculate a number here for A or UI. So 49 over 204. Okay, hold on. Spit it out in English, Michael, would you? UI for the first book would be 49 divided by 202, and that'll give me 0.243, I think it is. Okay. And then I take a look at UI for number 2. This should be a 1, sorry. UI 1. And I'm going to go look at 63 divided by 232. And that'll give me a number of 0.272. And I keep doing that all the way down till I got all 26 samples calculated. Okay? With me so far? Then I take all these U's and basically average them out, which will get us to 116. Okay? So there's going to be a little bit of deviation based on how you do this. So whichever one you feel the most comfortable with and think that's right. Cool bit is if you're doing this by hand, I would tally all the errors, all the number of pages, and do it the way I did it up on top here and get 0.102. But if I have an Excel spreadsheet, it's easier to go individually and sum these all up and then take the average of all the U's that you get and come up with the error. That makes sense, or did I do that complicated? Oh, and you good? Maybe. Maybe's okay at this point. Luke, you good? Okay. All right, so with a spreadsheet, that's going to be a lot easier. Now, what that does for me is actually calculating each U value for each set of books will make you have a better control limits than if you did the other way around. But after that point, once you make a choice which one you're using, and I'm going to go with the 116, you come back to upper control limit U, and this is going to be the outer one. I'm going to do U average plus 3 square root of U average divided by A minimum. Okay. And that'll equal, do it this way. That'll be 0, come on, write it nicely. 0.116 plus 3 square root of 116 divided by 202. Yeah, because 202 was my minimum number. Okay, so that's based up here. Oh, I didn't explain that, did I? Hold on, back up 1 second here. So the AIs, I'm looking for, when I wrote down A minimum 202, it's looking at the number of pages down through here to see what was what. Okay, so the smallest one just happened to be 202 up here, and the max was 770, and that was over right there. Okay, see where I got that from? And then my A average became the difference between those two. Following, Owen? Okay. Henry? Ryan, you good? Okay. All right. I didn't explain that well. I didn't explain that at all before. I just wrote the numbers down. All right. So when I get here, I have an upper control limit that's going to be, outer upper control limit is be 0.188. Okay. And then if I do the lower control limit, for the outer, it'll be the U minus 3 square root of U over A minimum. Okay. And put the numbers in 0.116 minus 3 over 0.116 over 202. And if the math's all right here, that should wind up as 0.044. Okay. Then my upper control limit for U on the inner will be U plus 3 average of U divided by A max number. Okay. And we will put that in as 0.116 plus 3 square root of 0.116 divided by 770. Okay. And that leaves me with a 0.153. And then I have a lower control limit for U on the inner. And it's the same equation, but minus 3 version. And that gives me a number of 0.079. Everybody keeping up with me? Am I going too fast? No? Okay. So let's put that on a chart here so you can see what's what. So this would be 0.188, 0.153, 0.116, and then 0.079, and then the outer lower will be 0.044. Okay? And then basically what you do is start plotting your UI values in this entire chart, because this is UI. So as we go down this, we'd have a 243. Yeah, 0.243, which would be out here. Okay. And then we'd have the next one was 272, be up there. So these particular first two are out of control and not something we can actually deal with. Okay. But then we're going to get some like 0.20, or book number 24 is 051. So way over here. So this would be 1, 2, and I'm going to go all the way over to 24, and that would be 051, which should be right about there. Okay. Yeah, Zach.
So is that your errors per page in your books?
Yep. Well, not the errors per page. Let's go back up here for a minute. It's this number, errors per page divided by this gives me the UI. Okay. So the UI is the average value of defects per page. Okay. So we have 49 errors on 202 pages. Okay. So how many errors per page? And that's the UI bit. Okay. So when I come down here, I'm plotting UI here. So this number was 0.243. This one was 0.272. And this one happened to be 0.051. Okay. And that's what you're plotting. And what you're looking for is which book had the most number of errors and which was in control, which were out of control. Okay. Did I do any other ones here? Well, we can do them. So book 18. So let's put 18 in here. Okay. That had, well, let me do this. The UI, well, U of 18 would be equal to 51 is the error on the page, and there was 302 pages in that book. Okay. And that became a 0.169. So that would be 0.169 would be someplace up there. 0.169. Okay. And as long as we're having fun here, I might as well do this one. U1, not I, 1, was 49 over 202, and that came out as 0.243. And then U24 was, get out of there, U2, 33 defects divided by 652. and that became 0.051. Okay, so that's where those numbers came from. How are we doing on time here? It's 5. Okay. So I could do a whole bunch more numbers. Do you want to do them just for the sake of doing them? No? Okay. Then watch where the numbers go, okay? So all the points literally do this. We go up, down. We got a point here. Then we're going to go down inside here. We're going to go back up here, here, down again, up, down. And by the time we get all done this, we literally have left myself no room to do this. Point 18 here was this one. This one went all the way down to here, all the way up to here, all the way back down to here, and then down inside here to another point, over and up. Okay, so for the lack of your sanity and mine, we're just going to put a break in here. So where that break is, I left numbers out. Okay, but what you can tell is we can see which ones are in control, which ones are out of control, which ones have a really critical thing we got to go look at. So numbers that fall between your inner and outer upper are something we got to go look at. Okay. Numbers that fall between your lower and inner is something we should go look at, but not so much so that it bothers me to go worry about that, because that's a really small average number there. It's those big ones that I want to go catch. Okay. Now, once I solve the problems on the bigger ones, then I'm going to replot this chart and come back and start working at the other ones. Okay. So it's never a one control chart and you're done stuff. This is always going to be, this first control chart establishes your boundaries of whether your process is in or out. And then you're going to come back and redefine it again once you fix the other problem. Okay. And then keep looking for those. And what you're trying to do is eliminate to smaller and smaller steps. So these charts may look like this big, then they'll shrink, and they'll get bigger because something else goes wrong, and they'll come back and shrink again. Sometimes you'll shrink them all the way down and think you're good. And then if you don't keep control and looking at those charts, they're going to get bigger again. Make sense? So it's one of these processes with quality control is you can't just say I'm good. Somebody's going to screw something up. Okay? Cool. All right. It's 5. Where are we at here? Actually, probably a good place to stop right there because I got to get into the next charts we're going to do are the variable charts, the X bar and R and the moving ranges. Okay, I'm going to put up, today's Thursday. Hopefully tomorrow I'm going to put up the exam that you can play with next week. And then I'm going to put up one more homework assignment for a C chart and have you build it. Okay. Anybody got questions? Okay. I'll see you all later.